recording has started. There we go. Send you this. Okie doke. So there typically is a slight lag between the camera to the TV and the recording thing. We'll make do with it. We'll see how it does. It may or may not be beneficial to record them, but we're here. So top of your page, write equivalent expressions for me. If you're not sure how to spell it, it's going to be on the screen in just a second. So yesterday we did the entry task for equivalent expressions, and you guys went around the room and we kind of looked at some different problems that you've really never seen before. And it took us a minute. And I will say, we're going to reuse this as like an exit task as well as we did with the entry task. But we kind of got to see how expressions can change a little bit, and we got to see how they can be related. And that's basically what the word equivalent is like, how are these things the same? Something is equivalent, aka it's equal. And so what we're going to work through today is kind of defining some of those properties that we're going to use and looking at the two main pieces, and then that'll be it. So let's kind of roll with this. Your first word is equivalent expression. And if you Googled it, it's probably not going to tell you this definition. This is more of a simplistic Miss Young definition, and we're going to just call it equal problems. So you've been doing equivalent expressions since elementary school, when you learned the concept of commutative property, which we talked about a little bit yesterday. You guys learned that in probably third grade, maybe even before, but that the understanding that 2 plus 3 is the same thing as 3 plus 2. That's an equivalent expression. Equal math problems. And there's benefits sometimes to doing math in a particular order, because sometimes we compare numbers that go well together in our head. Particularly, I don't know about you guys, but like if anytime I can add a 10, I'm going to go that route. Yes, ma'am.
There's something wrong with it.
All right, just leave it or put it right here and then get you another one. You're cool. All right, so sometimes we want to rearrange numbers simply because it's going to make the math easier in the long run for us, and that's kind of what we want to look at with some of these. Okay. So we got to go through a few properties. Some of them are relevant, some of them are review, some of them are new. I won't say any of them are brand new per se, just that we're going to apply letters to them, whereas in elementary school we only did them with numbers. Properties of operations. So I'll give you a second to jot that down for me. We really won't be in your calculator too much today. But I will show you how you can utilize it as a tool. But most of this stuff, because the numbers are pretty small, you can do definitely all the positives in your head. Occasionally you might have to go to your calculator for the negatives, but we have to remember that even though our calculator does have the ability to type letters, it doesn't have the ability to process them as expressions and stuff like that. Okay, so this one you probably learned first grade, maybe even kindergarten. Your kindergarten teacher may or may not have called it this, because you're talking to 5-year-olds and gotta use little words and stuff. But the identity property of addition, does anybody remember anything about that? I don't expect you to be honest with you, but when I tell you what the skill is, then you'll be like, oh yeah, we learned that, but she probably didn't call it the identity property of addition, or he. I can't gender assume you had a female kindergarten teacher. Most people do though. Anybody? Going once, going twice? All right, cool. I'll answer the question. So let me ask you this. If I add 2 plus 0, what do I get? 2. If I add 1 million plus 0, what do I get?
1 million.
If I add negative 5 plus 0, what do I get?
Negative 5.
Negative 5. So what common thing do we see there?
It's all adding to 0.
And so what happens when you add to 0? What happens to your initial number?
It's the same.
There you go. That is what the identity property of addition is. It's when we add 0 to any number, it stays the same. And so you're looking at that skill knowing that it's super easy. It's something that you should know. But when we think about it in terms of our expression, I'm trying to think which problem. Think of it as that board over there. So yesterday you had the board where it talked about the game, and it said you got a bonus game that you didn't have to pay for. So in theory, nobody really got that one correct because everybody kept putting 2G plus 1. So plus 1 would indicate that we had to pay $1 for that game. In the problem, did it ask us to pay anything for the third game? So what really should we plus it with? 0. So would that have changed the amount we had to pay? No. So that's kind of where the identity property of additional come in, is sometimes all of your letters will cancel each other out and it would just be a plus 0. Now in math, is it necessary to plus things by 0 sometimes when you're trying to simplify an expression? Do we always have to show the plus 0? No, because what does it do? Does it do anything?
Yeah.
No, it's just there. So while it's mathematically okay to put the plus 0, like in that situation, 2G plus 0 lets us know that 2 games plus the free one. In theory, we don't have to do that because adding 0 doesn't change anything. You could have just put 2G and been fine. But again, things that we didn't know yet because we just did those as entry. So probably in second, start of third type grade, you learned about this one. Identity, except for I misspelled that. Let's try again. Identity property of multiplication. Give you a second to write that one down because it's kind of long.
Yeah, I was gonna say I can't remember what I had for breakfast yesterday.
So kindergarten's been a minute, huh? Yeah, it's all good. The thing is, with some of these, is like you use them more often than you think. Nobody just put like a fancy name to them. And realistically, I don't care about the fancy name. That is what it is. It's more so that you understand the skill set. So don't worry about not remembering this stuff. I don't remember much either. It's cool.
I remember learning about this one, I just forgot what it was.
I gotcha. No worries. I'll give you a second to write it down. Once I tell you what it is, you're going to be like, oh yeah, I remember that guy. So the identity property of multiplication. I'm trying to think. That was one of these problems. Anyways, you got down to where you just had like x plus 4.
We did multiplication in second grade.
Sometimes you start introducing it, but more than likely it was third grade.
Yeah, I did third grade.
Yeah, more than likely it was probably third grade that you started doing your multiplication tables, stuff like that. So you typically start with this, in terms of multiplication tables, you start learning how to multiply by this number, and then you work your way up. But basically, yeah, what do you think it is? Times 1, very good. So the multiplication identity is dealing with timesing by 1. And what happens when we times by 1 or multiply by 1?
You get the same number, it's pretty much like you're adding it to 0.
Very good. Okay. So what we need to understand here is kind of the same thing that we understand with this one. Is if we multiply any number by 1, multiply any number by 1, it stays the same. So where this is going to come into play, and I do not care now, right now because you're learning it, if you keep the 1 on some of your problems. As you progress through your math, your teachers will start to have the expectation that you drop that 1 because we get this understanding of what it is. But you can write this down if you want to. If you need an example of it, I'm just going to write it up here so we can see it. What you need to understand is that 1x, just like that, what's happening between the 1 and the x here?
It's getting multiplied.
It's getting multiplied. So does that change the value of x? No. So basically what we understand in expression writing is that we can drop the 1 and just have x. And so anytime you have a letter that has that by itself, it's understood to be being multiplied by 1, or it's one of those items. But we drop the 1 because multiplying by 1 doesn't impact the problem at all. When we first start going through these, especially combining like terms, if it helps your brain to put a 1 in front of the x so you know to count that, I'm totally cool with that. But as you go down through and you learn these skills a little bit better, you're going to just start writing things as the x alone. But that's why we can drop the 1, is because it doesn't change the value of our x. Cool? Cool? All right, we got 2 old properties, and then we'll start in the actual real ones. So we talked about this one yesterday, and these are all just review stuff. Does anybody remember the commutative property again? There you go. So my kids went to Divide. Well, I still have a kid there. But they went through Miss Redden, and she's Miss Pomeroy now. But anyway, if you had her, she did call it the flip-flop rule. And maybe every elementary teacher calls it that. I don't know. I just remember the boys going through that and learning about it in 3rd grade. So this is probably 3rd grade is when you pick this up. And what does it do again?
It flips your numbers.
But
Like,
you can only do it in addition and multiplication, I think.
Can you give me an example?
like 5 plus 3 would be 3 plus 5, and then same thing like multiplication.
Very good. Very good. Yep. So community property is the ability to rearrange. No, we'll keep it simple. Plus or times problems, multiplication problems. And we'll put flip-flop rule in parentheses. So the key factor here with this guy is that it only works with addition or multiplication. So we went through the concept of KCC, keep, change, change. What did KCC do?
It kept the first number, changed the subtraction to addition, and then it changed the second number
To its.
to its opposite.
Very good. So realistically, 3 out of the 4 things, and there is a way to make division work as well, we can change them into things that are allowed to be flip-flopped. Because the minute you see subtraction, if you want, KCC that thing, and now it's a plus problem and you can rearrange this. Where this can be very beneficial is when we jump into combining like terms, or even when we're doing distributive property. If we can rearrange the numbers so where all the x's are on the same side, all the regular numbers, all the y's, whatever you're working with, can group all together, then we can see how to simplify it easier. So we use the commutative property to just kind of rearrange our problems to make the math easier to see. Okay. Do you want me to do an example, or you guys understand commutative property? Everybody chilling? No chill? 0 chill? Okay. All right. And then the last one, which to me, I don't really, it is what it is. Associative property. It's fine. We don't use it that much. I just go over it just to be safe. Is the regrouping. And again, it kind of ties in with if we can group things that go together, it makes the math a little bit easier in the simplification process. But associative property is the ability to regroup plus or times, addition or multiplication, using parentheses, which really, parentheses isn't the right word to use, but that's the one we're going to use. It's realistically any grouping symbols. We could use brackets, we could use the fancy brackets, but parentheses is the simplest way to put that. Again, this skill really just goes hand in hand kind of with commutative property. It's like if we can get all the things that go together in the same fence, then we know that these belong together. And when it comes to combining like terms, that is realistically like the biggest struggle kids have. And so if you can figure out what's allowed to go together, put them in the same fence, and then do your math, we typically do a little bit better. So this one might need an example, so I'm just going to jot this down really quick. So if we have this, and we've grouped the 5 and the 2 together. Well, 5 plus 2 is 7. 7 plus 8 is harder math to do in our head. This allows us to regroup this to where we have numbers that are more compatible. Because now I can do that math really easy, right? 2 plus 8 is 10, 10 plus 5 is 15. I get the same answer regardless, but I have a little bit of an easier way to do the math because these are more compatible numbers. And so I can group them in the same fence, do that math really quick, then take it from there. And that's essentially what associative property is. Everybody chilling? Everybody cool? All right, let's get into some 7th grade stuff, and then we can call it a day because it'll be time to go. So the 7th grade stuff is your combining like terms. And I went over this a little bit at the end of last year. We didn't get to go into it very heavy, but some of it may seem like a review, but I feel like it's worthwhile going back to. This is very much a skill that you are going to use for the rest of your math career. You're going to need this again in college algebra. Definitely need it next year with Mr. Miller. Some kids were talking about how they've heard the 8th graders complaining about having equations with variables on both sides and all of that stuff. And it all comes down to learning this base skill, realistically all the base skills that I'm going to teach you this year when it comes to the algebra part. And combining like terms is a massive, massive piece of that, because when you have variables on both sides, you're typically going to have multiple variables to combine. Yes?
I think I do with this one.
All right, tell me about it.
So when you combine like terms and you have two variables that, like, say you have a 4x plus 3y plus 2x, would you combine the two ones with the x on it to make 6x plus 3y or whatever I said?
Very good. Why can you not put the x and the y together?
Because it's like two different things. It's like hamburgers and hot dogs. You
Very
can't
good.
Really combine them.
Very good. Lewis, what you got?
Can I use
Send me a pass and you can, yeah. All right. Combining like terms. If you let me finish the notes, I can put you one in just a second. I just don't, I'm not in the mood to get yelled at by Mr. Crouch today. So, what Hoff said is correct. Basically, it's the ability of what we can combine in math and what we can't. And so, this definition is not what you're going to get on Google. Ability, I think I misspelled that, but we're going to roll with it. To combine, and I'm going to put it as a fruit, apples to apples. And I'm going to show you some examples so that makes more sense. But basically when it comes to combining like terms, it's knowing what we're allowed to do in math and what we're not allowed to do in math. And Hoff did x's and y's, and we're not allowed to put those together, and you got to treat them like they're two different things. And so she said the x's were hot dogs and the y's are hamburgers, or vice versa. And if we have to count, for dinner, say we're cooking dinner, and we can't say that we just have, 10 items. We have to specifically divide them up on the menu so that we know that we have, 4 hot dogs and we have 6 hamburgers. We want to keep that separate. So that way, if we're like working at a business, we know what we need to order more of. If we're, doing, inventory at the store or at the restaurant, and it's like, okay, we need to order more hot dogs because we only have 4. Well, I can't walk in and say we have 10 things. 10 things of what? So we have to be very specific about keeping those separate so that we know we have x's, we have y's, and we just have regular numbers. Go ahead and sharpen your pencil if that's what you're doing. So we're going to give a few examples of what we can do, and then a few examples what you can't do. I will have kids, even though we go over all of this, still try to push everything together. You guys have been so trained since elementary school that everything has an answer. And sometimes in math, the answer is just a different problem. Sometimes we cannot get rid of everything to just get down to one numerical answer. And so it's a little bit unsatisfying if you really like that concrete math, because it's like, well, what's the answer? There isn't one. The answer is just a different problem. And so that's kind of an issue. What we see is we want this finite answer and it just never gets there. So don't force a finite answer. Understand that it's possible just to not get a perfect answer for these. Now, to go back to elementary school, if you were given this problem, what could you do with it? Sorry, the lag is there.
You would just add them up to 8.
Yep, you would just combine your like terms. These are like terms because they're the same type of thing. They don't have any letters, any of that, and it is 8. Let me find it. Do you have to go pretty bad, or are you chilling? Okay. I'm just going to say pass thing being weird, mostly because I don't want to put your pass on the screen that I'm recording. See, Young, if you see Mr. Crouch, run away. Tell him Mr. Miller sent you. Okay. All right. So whoever's listening to these notes, that's how we're surviving. Okay, thanks. All right. So same thing is now going to occur in 7th grade, and really we kind of looked at this a little bit in 6th grade. If we take those same numbers, but this time I put a little friend with them, and that friend's an x. Can I do that? Can I do something with that?
Yes.
Yeah, what can I do?
You can still add them up because they're both x, so it's apples and apples. You combine them up.
So how many apples do I now have?
8x.
8x, right? So the one thing to remember that when you're combining like terms is to kind of think of the letter or the variable as the parasite, or aka you could even think about it as the worm in the apple. All right, so we got apples to apples. What we don't want to forget is there was a worm with it. Okay, so make sure that when you combine your like terms that you bring the letter with it. If we just drop the letter and call this 8, the rest of our math isn't going to work out. So if they have a letter attached to them, unless it combines down to be 0, that letter always stays the course, okay? Kind of just to remind you that if it's a singular x, like that, what is that considered? So,
Times that number.
yeah, so it's a 1x. For some reason, not every kid, but I've seen it a lot over the handful of years I've been with 7th grade math, is they treat an x by itself as a different fruit. Just understand that this is like imaginary 1, and I just kind of did it in dots so you can think about imaginary. It's this imaginary 1 in front of it. So it counts as its own apple, even though it doesn't say it's 1 apple, but that's what it's inferred to because of that identity property of multiplication. We don't have to multiply by 1. So how many apples do I have?
No. 6x.
6x. Yep.
Sorry, I was
No.
doing 8 and 2, so I was about to say 9.
No, I got you. So yeah, so this is considered 1 apple. Any x by itself, just hanging out, is 1x plus the 5 other x's. We have 6 x's. Another thing that messes with kids' heads is if they're negative. So a negative 3x plus a negative or a positive. Let me rewrite that. If one's negative and one's positive, like that. Again, things that we can do and what we can't do. Negative numbers are still numbers, right? They're still calculatable and all of that. So for some reason, kids think that because something has a negative, it's now a different fruit. But that is not the case. This is plus. Sorry, I kind of messed that one up. Shouldn't write in pen, but here we are. So just because one of them has a negative does not mean it's a new fruit. If it has a number with a letter and any type of number is there, it's still, calculatable. So we can still do this because both of these numbers are x's. So this is where your calculator can become your friend. If you're unsure of a negative 3 plus a positive 5, that's the part we can put into our calculator. We're going to drop our x, which probably for some of you should probably drop your x in other capacities, but that's a different story. We're going to drop our x and just do the math part in the calculator. And then when we get our answer of positive 2, you just got to make sure you bring the x with you. Okay? So if you still struggle a little bit on your integer piece, totally use the calculator as a tool. But just make sure that you understand that the x can't go into the calculator. If you use the x button up there, it's not going to give you the right answer. We don't necessarily have to write it down, but this same concept applies to fractions and decimals. If you have a fractional x, which, I can write it, I don't care if you guys do, if you want. If you have like a fractional x plus even like a decimal x, those are still integers. Those are still numbers, and they're still parts of the apple. You have half an apple plus another half of an apple. How many apples do you have? You get 1 full apple. Okay. So negatives, fractions, decimals, whole numbers, the whole gamut. As long as it has the same letter, we can do that.
Is that all we're writing?
I wish. We got a couple more things to write down. Yeah, these notes are a little extensive, more than usual, but if we knock out both properties today that we have to learn, then we don't have to take notes next week. And then this is all we're doing today. So just a really quick recap of what you're not allowed to do. You are not allowed to put those together, okay? There will be somebody in the course of my day today that will tell me that's 8x, but it's not. Literally all this can ever be is the same thing it is.
Because you can't add one number that has a variable to it and one that doesn't.
Correct. This is like your hamburgers and hot dogs, okay? We can't say that we eat items. We have to say we have 5 hamburgers and 3 hot dogs. Yes?
What about the problems that have like 5 plus 3 plus x? Would that be 8x, or would it be,
Like-
would you have to put an x
Like
on one of
5 plus 3 plus x, like that? Is that what you're saying?
yeah.
So this would actually be the only thing that we're allowed to combine would be this, and your final answer would stay as 8 plus x. We can't force a letter onto any number that doesn't already have one through addition. The only time that, and we're going to look at the next skill, which is distributive property, the only way you can give a number a letter is through multiplication. And so in this case, we are not allowed to do that. You are also not allowed to put together different letters. So this was Emma's kind of example there. X's and Y's, they're 2 different fruits. Apples, oranges, hamburgers, hot dogs. However you want to put that. There's nothing we can do to this problem. We can't force it together and call it, you can write this down, but understand it's wrong. You can't force it together and call it 10xy. or vice versa. It is literally staying this. The only option you have to change it is if you really wanted to. You could use commutative property and flip them and have 5y plus 5x. But realistically, there's nothing we can do to change that problem. It's just living out there in space until somebody tells us a value of either variable. And this is probably more so a Mr. Miller thing next year, not something you're going to see here. If you have letters and then letters with exponents, they are considered different. Like these are considered apples, and these are considered like a special apple, like green apples. So you got red apples and you got green apples. Yes, they're both still apples, but these are specific. So we're not allowed to add those together. They have to have the same exponent in order to be put together. Does that kind of make a little sense?
Yeah.
And I promise we're going to do a ton of practice with this next week, so don't sweat it if you're like, what is this lady talking about today? All right. So let's kill distributive property, and then we'll be good. Again, guys, we could do them in 2 lessons, but if we kill the notes today in one big batch, we don't have to worry about it. So you did learn about distributive property in probably 5th grade, 4th grade, and then we touched on it a little bit last year when we were talking about least common multiple and greatest common factor, because when you factor, essentially you're doing the opposite of distributive property. The biggest issue I run into with kids with distributive property is they forget to distribute to both people. They only want to distribute to the first number. But what distributive property is in a nutshell, is the ability to multiply the outside number. So you're going to multiply the outside number by all, that's the key word, the inside numbers, and I'm going to put variables there too, because realistically it's all the terms. Anything that's going on inside the parentheses, whether it's numbers, letters, negatives, positives, fractions, decimals, whatever's inside those parentheses is what we need to multiply with. And so the example I use every year, and again we might have touched on last year a little bit, and they're not even here today, and I'm going to use them as an example, is going to a birthday party for the twins. Yeah, and so you guys might remember me talking about this a little bit last year. So Jake and Jace are twins, and it would be very impolite if we came to their birthday party and we only brought one of them a gift. So we only show up with Jace a gift. And Jake's just going to be sitting there being all sad, right? Because that's not cool. And that's essentially what distributive property is we have a gift on the outside. That's your number on the outside. And then you have Jake and you have Jace waiting inside their house for the birthday party. And so how we use distributive property is when you walk in, you want to distribute or give Jake a gift, and you want to make sure you give Jace a gift. And so what that equals is you have Jake plus a gift, well, times a gift essentially, and you have Jace times a gift. And so both of them are happy, okay? And that's what the problem would be. Now, it doesn't have to be a plus sign in here. This can also be subtraction, this, that, and the other. But the biggest key factor is that we recognize that we have to give a gift to both numbers. And by giving that gift, you do it through multiplication. So we'll do a quick example, and then we'll close these up. This is a really easy skill when it's all positive. So if you have something like 3 parentheses x plus 2, we're going to do math we can do in our head. If it helps you, and I'm still been doing this for a long time, and if there's like lots of distributing to do in a problem where I have multiple sets, you'll still see me do arrows. If it helps your brain to do arrows, okay? Draw an arrow to the first one, draw an arrow to the second one. If it helps your brain to expand them and show the multiplication, because right here, this is saying 3 times x. You do not have to do this step. I'm just saying if it helps your brain, write it out. 3 times x plus 3 times 2. You're going to get to the point where this all happens in your head for the most part, but until then, feel free to do this step. This is kind of like the understood math that we do mentally, but it can be physical math. So what is 3 times x?
3x.
Very good, 3x. And then, what is 3 times 2?
6.
6. And that is where this problem stops. We cannot force it together because we only have one apple and some oranges. We cannot make them be anything that. We can't call this 9x. We simply have to stop until we either put an equal sign here and make it an equation, or somebody comes along and says, hey, x's are worth 5. Now we solve it. And so this is where that, like, we don't get a finite answer comes from. You want to find the answer. There it is. That's all. It is done. Nothing more we can do.
If it was X, would the answer be, or if it was 5, would it be 31?
Yep. No. 15 plus 6, 21.
Oh, I didn't.
No, you're cool. So the only place that this gets a little tricky is when the negatives come to play. So we'll quickly do a couple of those. We'll just do, actually, yeah, we'll do 2 and call it a day. So if you have like -2 and then parentheses 4x minus 3. So inside that is going to be a plus or a minus, okay, because we're separating these into terms. My biggest piece of advice, take it, leave it, get it wrong, I don't care. I mean, I do care, but still, is to KCC any subtraction, okay? The reason why we KCC it is because knowing how to multiply them better, I guess. Mr. Miller may get on to you next year because he doesn't believe in the KCC method. He thinks that you should have this understanding of it. But in 7th grade, we're supposed to teach KCC, so it is what it is. But what I would recommend is we KCC what's inside here. This -2 is going to chill, 4x is staying, but I want to keep change this. So what is this going to change to? The minus is going to change to a plus, and what does 3 change to? -3. And the reason why that's important is because we're going to have to multiply by a -2. And sometimes when that happens, kids forget a negative times a negative, because this -3 is the same thing as saying -3. And that's really important that we understand that this is going to eventually become a plus sign. So we would do our arrows. This is where your calculator can come in handy if you're not sure of your multiplication. But what is a -2 times a +4? -8. Very good. Because a negative times a positive is a negative. It has a worm in the apple. It is the apple, so we bring the x with it. And then we're going to do a -2, now that we have the understanding because of KCC, times a -3. And what's that going to give us? 6. +6. And so what happens right there is kids will forget that is negative, and so they'll put this still as a -3, and that will cause them to get the answer wrong. So I believe that KCC can help this skill quite a bit. Again, we can't do anything more. This problem is done, and we have to wait until something else happens. So last thing I will tell you is that sometimes they will throw a negative sign outside of your parentheses. I'll just kind of jot this down for you. If that occurs, what you need to understand is this is the same thing as if they told you -1 was hanging out there. So if it helps you, just put a 1 there. So you're distributing the negative to the parentheses. In some of your like larger problems, it'll be a subtraction. You'll have like a distributive here, and then this is a subtraction sign hanging out there. Treat it like a -1. And so you would give this here, and that's going to give you x. Give this here, and that's going to give you +4. So distributive property of a negative is just like distributing -1. And then if you have to distribute a variable, if they have an x out there and they just have numbers on the inside, numbers on the inside means that we can just do PEMDAS. So what's 2 plus 3? 5. And what's 5 times x? 5x. And that's where that one would end. Okay. We are going to do a ton of drill and kill with this. I truly think that this is a skill where drill and kill can be very, very beneficial. And all that means, guys, is that we just do some practice on it. We'll do some boards up. We'll do some whiteboard stuff next week. We'll do, some papers on it. We'll touch the real world concepts with this, but most of the skill is just understanding how to simplify those expressions, because that is really a skill you need next year, especially, well, realistically, all the way to college algebra, is understanding how to simplify them down to where you can actually solve your equations. Okay, so that is the end of the notes. We'll call it a day because we only got a couple minutes left in class. So let me kill the recording before you guys start moving to put things away. That way it doesn't get loud. Stop recording. Bye if you're listening to this.